All right, so this is sedimentary rock. So basically, if we look at sedimentary rock is formed from sediment. So how do rocks become sediment? Well, all rocks can become sediment after they break down. So it could be weathering, and erosion is usually the way that rocks break down into sediment. So this could be igneous, metamorphic, or other sedimentary rock. And basically just wear and tear from freezing, from water, from crumbling, like gravity, for example. All of these things can crumble rock into sediment, which is basically just broken down rock. All right, so if we look at the texture, we describe rocks by texture. So igneous, metamorphic, and sedimentary rocks are all described by texture. Texture is different for each type of rock. So for sedimentary rock, we look at what it's made out of. So if we look at the picture on the left, conglomerate is made out of other rock fragments, little rock fragments. Sandstone is made out of sand. Siltstone is made out of kind of like a really fine sand. And then shale is made out of mud. So you can see it goes from really coarse to really fine grained. And so those would be our different types of texture for sedimentary rocks. All right, and then little sediments, of course, are just small broken down pieces of rock. And that could be formed from water, wind, glaciers, gravity. All of those things can break down rock and form tiny little rocks. And if you go to the beach, you guys can see this. So the beach is full of sediment, sand. It's been worn down over, maybe hundreds or thousands of miles as it comes down from the mountains. And so it gets to be really soft on your feet. So it's really smooth. You can see these sand grains in this picture are very smooth on the outside. And so that's just from constant tumbling, weathering for, sometimes thousands of years. All right, so the types of weathering, there's a couple types. There's chemical weathering. So chemical weathering is the picture on the left. And chemical weathering would be the rock is broke down by changing its chemical bonds. So basically dissolving would be a type of chemical weathering. And it's chemically changing. So it's dissolving into water. It's dissolving into something else. So limestone does this in the presence of acid rain. The picture on the right is physical weathering. So you can see these rocks are the same. They're not being dissolved. They're just being broken down into smaller and smaller chunks. And this could be because of frost wedging. So frost, ice, water gets into the cracks. When it freezes, it expands and breaks the rock, and then it crumbles down. And then you can also see it's moving down because of gravity. So gravity is also pulling this at the same time. So that would be physical weathering. So the difference, physical weathering is just breaking down into smaller and smaller pieces, whereas chemical weathering is dissolving. So it's breaking the chemical bonds. All right, so looking at this piece of rock, we can see that some rock, like things that are made out of granite, like quartz, for example, it doesn't break down as easily. So not all rocks break down as easily. So that's why when you go to the beach, you only tend to see maybe one or two types of rocks that make up the sand. So it could be dark sand because there's basalt breaking down. It could be light sand because there's quartz breaking down. But the things that are more resistant to weathering are the things that generally make it to the beach. So we can see in this picture, we've got this granite breaking down. And so this gray rock that's in here, this might be felsite or something. So this mineral here is resistant to breaking down, whereas this pink stuff, whatever that is, it looks like it's dissolving, it's breaking down faster. So by the time it finally gets to be sand, the only thing that's left is this gray. The pink has dissolved or completely weathered into maybe mud in that case. All right, so erosion, there's a few different types of erosion. I've got those pictured here. So erosion just means that it's moving, transporting sediment is basically what it means. So the four types, we've got wind, water, gravity, glaciers. So you can see here we've got some real erosion. So you can see there's a little gully here because of excess rain. And then we've got glaciers here in this picture. So glaciers just basically scratch and erode the land as it goes down the hills. And then gravity, the picture on the right here. So gravity is basically on this picture, it's just tumbling down, because of gravity, basically. And then you can see this is wind. So wind, we've got the sand here is whipping around, and the sand acts as a really good sandpaper. And so the sand is breaking this down and forming these weird, bizarre shapes like we see in a lot of places in Utah, Arizona, lower parts of Colorado, New Mexico. We see a lot of these types of formations because there's a lot of sand and wind, and that's eroding the already weak rock there. All right, and then deposition. So that sediment has to go somewhere. So it erodes by one of those four agents, but then it goes somewhere else. It doesn't just disappear. And that would be deposition. So you can see in the mouth of this river, in this delta, that the water here is breaking down, or not breaking down, but it's carrying the sediment. And then the sediment is being deposited as the river slows into this larger body of water. It can't carry as much. And so when it slows, it drops that sediment, and that sediment becomes deposited. And so that can happen along rivers, at the mouth of the river, along the river banks, along the inside of the curve. So here you can see in this picture up here, this is the inside of the curve. And that's slower, less velocity, so less stuff that the water can carry. And so we tend to get banks, these big like sand banks forming on the inside curve of the river because it's slower. And then on the outside of the curve right here, this is where erosion is occurring. And then up here, same thing, erosion's occurring, and you can see it actually breaking down this hill right here. And then you can see there's sandbanks here, and that's deposition occurring. So you've got erosion and deposition occurring in this picture. So when it carries, so let's say the water is carrying sediment. And so if the water slows, so think about the Sacramento River in the winter versus the summer. So the summer, if we're not letting a lot of water out of the dam, the water is flowing fairly slow compared to the winter. Let's say that we get a really heavy rainfall, then we get lots of sediment being carried. Well, that difference in velocity also is a difference in amount it can carry and the things it can carry. So if it's going really slow, it's only going to carry very fine grained particles. If it's traveling really fast, then it's going to be carrying heavier things. So if we look at this picture, this is called graded bedding. And so graded bedding is where you've got graded, meaning that it's different, it's sorted by different size. And so you can see this is the heavier stuff. So the water was flowing very fast when it carried this. And then you get finer and finer grains as it goes slower, the finer and finer things settle out. And then you can see in this drawing over here, you can see two different graded beddings. So this could be the course of, maybe a season. So this could be winter and summer of one season. This could be winter and summer of another season. We tend to see this where we've got millions of years. So let's say that the Grand Canyon, for example, we tend to see a lot of graded bedding because that's millions of years of history. And we see a variety of things. Sometimes there's been an ocean on the Grand Canyon. Sometimes there's been a river like there is now. It's been a lush rainforest before. So that area, millions of years, a lot of climate has changed in that area throughout that time. So we tend to see areas of water, and then areas of sand, and then areas of where water used to be. And so we can see this graded bedding layers, and you can really see here in the picture. And then there's a lot of energy in transportation. So if we're transporting sediment, you guys have picked up sand or picked up rocks, they're heavy. And so you have to have a lot of energy in order to carry that. So that wind, water, glaciers, those carry a lot of energy. And you can see this is kind of a cool picture. All this edging of the rock is formed by sand. And then we've got these weird layers, which we'll talk about later. But we've got these layers that are kind of diagonal, and then you've got these layers that are horizontal. And that's because of different processes that occurred there. But what I really want you to see is just the wind erosion. So the wind whipping through here, this is a different layer of rock. It's a little bit sturdier. Maybe it's a quartz. And then maybe this is some type of hematite or feldspar or something. And so that's why you get these lines that aren't eroding as fast, is because it's a different type of rock. And then here's a glacier. So a glacier comes down, and all of this stuff right here is all deposited from the glacier. So this glacier is carrying all this sediment down from the hills, mountains. And as the glacier retreats, so the glacier is melting, you can see that this is just deposited sediment. So as the glacier retreats, all the stuff that the glacier is carrying basically just gets dumped. And so you get all of this sediment. If we were to look at this rock, we would tell that a glacier deposited. One, there's a bunch of different things that we'll talk about later as far as how we know that, but it's also not graded. So you can see in this picture the graded bedding that we're talking about. You're not going to see that with a glacier. And the reason you don't see that is because it's not flowing water necessarily. It's just all carried together. And then when it stops, it just is dumped. So it's not settling out as it gets slower and slower as it's moving. So here's some different layers, and we can see this is really typical of the Grand Canyon. This is not the Grand Canyon, but very typical of it. So we can see these different layers, and these different layers represent, this could be millions of years of time right here. And so we've got these different layers. Colors represent different minerals that show those different colors, different types of rock, different types of deposition. And then you get these layers that form because of that. And so notice how they're horizontal. So all layers are laid down horizontally. And this process of laying down these layers is called lithification. So sedimentary rocks form by lithification. And that's just the binding of these rocks together and those layers of sediment that are laid down. So this is only sedimentary rocks that become lithified as far as how they're formed. All right, so we have this lithification process, but how does that work? So basically you have these sediments being laid down. You've got mud, you've got sand, different minerals, you've got water that's compacting in there. So some of those minerals are going to dissolve slightly, some of them aren't. And so if they dissolve slightly, and then when the water disappears, evaporates, then those recrystallize and form minerals, kind of like what you see with the crystals that we grow on the sides. So the water evaporates, those minerals are left behind. And they're being compacted by weight. And then they're also being squeezed, the water's being squeezed out of it. So they become compacted that way. Like think about mud and squeezing that water out. And then any water that's left, when that evaporates, if there's any minerals dissolved in it, that becomes crystallized. And now you've got something that's compacted and squeezed together and held, bound together, cemented together by minerals. And so that's how sedimentary rock forms. And you can kind of see this process here. So cementing the rock together. We've got the water that seeps through like this. And then you can see the water is starting to disappear. And so basically the mineral, whatever this mineral is, binds that rock together. So this might be a sandstone or something like that. And so that then forms a solid rock. All right, and then if we look at the bedding, I mentioned graded bedding. There's certain features that we see with sedimentary rock. So here's some different features, and here you can see bedding. So this is graded bedding. And so we can see there's different heavier sediment that's right here, and then we've got lighter sediment up here. And so this might have been carried by water, is how we get bedding occurring. So water would be flowing fast, carrying these larger particles. Water is carrying slower, carrying less heavy particles. And then we get all these different types of bedding. So you can see these cross layers. So you can really see them here. You can see cross layers here. You can see cross layers here. So the only way that forms is if water is carrying it or wind is carrying it. So this would be wind or water. And so normally, let's say that there's water over this area. And so we get this kind of incline layers. And then let's say that now it becomes, after thousands of years, this area dries up and becomes a desert. And so you've got the winds whipping around and you're forming sand dunes. And so you can see this would be really indicative of sand dunes or water that used to be in the area. But we really see this a lot when we have water covered by a desert region. So in the Grand Canyon, we do see a lot of this. And so that's just called cross bedding. So it could be water, it could be wind that causes cross bedding. All right, and then ripple marks. So this is kind of cool. There's a lot of this over actually by Shasta College. This whole area used to be under the ocean. And so Shasta College used to be kind of the shoreline, I guess you would say, of the ocean a long, long time ago. And so we can, if we go over there, we can see ripple marks. And so these ripple marks were very shallow, like an inland kind of lake, I guess. And so water that sits over something and just barely moves, like maybe like think about Mary Lake, for example. The water kind of just sits there. The water does move when the wind blows. And on the bottom, undisturbed on the bottom, you would see little ripples on the sand. And so that's this cemented together. So basically, those ripple marks say that this was covered by water, really shallow water. And then the water evaporated, and then the minerals are left behind, cement together, and they form these little ripple marks. And these are like petrified. They're like, like fossilized ripple marks. So we can tell this area used to be covered by water because of those ripple marks. All right, and then we have different types of rocks. So you can see in this picture, there's different types of roundness. And so this tells us a lot. So if we see the angular, which is on the left, the angular rock tells us that there's not a lot of water. So this might be gravity that caused this rock to break. Or it could be maybe ice wedging. So ice gets in there, breaks it apart. But it wasn't flowing water. And the reason we know it's not flowing water is because flowing water makes things round. So the picture on the right, the rounded one, was definitely in a riverbed. So if we were to come across rocks like this, we would know how they weathered. So rounded tells us there's flowing water. Angular tells us that it was gravity. So what we found on Mars is that there's a lot of rounded rock and there's a lot of ripple marks. So what does that tell us? If we see ripple marks and we see rounded rocks, well, it tells us there used to be water. And so we know for a fact in some places on Mars, there used to be flowing rivers. And that's because of ripple marks, because of these rounded rocks. So we can tell that, the climate on Mars used to be a lot different. There definitely used to be water there. And we know that because of looking at the types of rocks. All right, and then these are little fossils. There's all kinds of fossils in here. And so they're basically just preserved shell, preserved life, preserved bone. I'm sure you guys all know what fossils are. But as they die, they settle down into usually like the ocean. That's pretty typical. We do find land fossils, but we find a lot more ocean fossils because they can stay undisturbed at the bottom for a while. Whereas on land, there's all kinds of things occurring that disturb it. But then more sand settles on top of it, and then basically forms a fossil. And this fossil in particular was a mass extinction. And so we can see lots of fossils of things. These were all ocean creatures that are, for whatever reason, died around the same time. And so that would be mass extinction, probably the Cambrian mass extinction, because this is ocean life that we're looking at. All right, and then we've got these different types of texture that we're talking about. So one is a clastic texture. So clastic is just made out of other rock fragments. So we've got three types here. We've got the clastic, big chunked rock on the left, and then we've got sandstone and we've got shale. So those are different like sizes of rocks. Clastic would be or conglomerate on the left would be the biggest chunk. Sandstone would be kind of in the middle, and then shale would be very soft because it's made out of mud. So you can see the size of the rocks changes. So big, medium, little, as far as the different types of sedimentary rock. And so we can tell here, this was maybe a riverbed, maybe the bottom of a gravity, like a cliff or something. Sandstone, this would be like the beach. Shale, this would be mud. And so this would be like a swamp or a bog or something along those lines. All right, so with clastic rocks, we have something called conglomerate. I mentioned that just a minute ago. There's two types of conglomerate. There's breccia rocks and conglomerate rocks as far as clastic goes. And so this right here, notice the rounded rock. What does that tell us? It tells us it was in a river, right? So this was somewhere near some flowing water. This was not. So notice how the rocks are just broken fragments. So they are broken because of probably gravity. So it's probably tumbling down a hill and forming at the bottom, whereas this is a riverbed. So this angular rock, the angular pieces in here are called breccia. And the rounded rock here is a conglomerate. So it's just rounded gravel-sized pieces. All right, and then if we look at something else with sedimentary rocks, there's a lot to look at with sedimentary, but we look at porosity, and so that's how easily the water flows through it. So if we look at the pore spaces here, the water's going to flow a lot easier through this picture on the left than it is the picture on the right, and that's because there's more pore space. So if the water's flowing through here, there's more places for the water to flow in and through, rather than over here, these pores might not even be connected, so they might just kind of flow and stop. So let's say we're looking at sandstone. If I were to pour water on sandstone, which would be like this, then the water is just going to seep right through. If I were to pour water on shale, which is made of a finer material, the water is going to pool up on top. So if we look at what a pond is lined of, so let's say that we're making a pond at our house, we wouldn't want to line the bottom of it with sandstone because it's not going to ever hold water. But if we line the bottom of it with shale, then it'll hold water. And that's because there's less pore space, so the water can't really seep through. So we look for things like this when we're looking for oil. So sandstone, the oil is not going to be above sandstone because it's just going to seep through. But the oil is often found near shale, and shale does not allow the oil to move through. So we find big oil and natural gas reserves, oftentimes associated with shale. All right, and then there's different types also besides that. So we've got that really fine grain clastic rock that I was talking about called shale. So very low porosity. That's what we look for when we're looking for natural gas and oil deposits. All right, and then we get some other features. These are called evaporites, and so that is just when you've got water evaporating. So these are salt structures, gypsum, halite. Those are all formed from water evaporating. Let's see, there's talc is sometimes formed like that, but mostly gypsum and halite. So this is halite on the left, this is gypsum on the right. And that's basically just from it being dissolved in the water, and then the water evaporates and it leaves behind these cool structures. So those are called evaporites. And there's a lot of minerals that are evaporites. There's some gemstones. Geodes are a great example of evaporites. All right, so this is how they form. So you've got this water becomes super saline. So you've got evaporation occurring. The freshwater inlet is very small, so there's not a lot of water flowing into this body of water. So not a lot of fresh water anyways. And then you've got things dissolving, and this becomes really, really concentrated. And then when evaporation occurs, you get this evaporate forming down here. So basically, as the water evaporates, all that stuff that was saturated in it is left behind, kind of like with the slides and the crystallization, the growing crystals on the sides that you guys did. All right, so just a few more things. There's biochemical rock. So that is when you've got something that used to be living, but it's also a rock. And so travertine is a great example. So travertine is similar to an evaporite, except for it's made from shelled creatures. So it's limestone basically dissolved and then layered. And then we've got this coquina, and that's made from shells. And you guys can see my kitty playing in the background. See it? So it's just made from shells. And then here we've got chalk. So these are big chalk limestone cliffs. And then here's some little limestone features that sometimes we see as little fossilized shells within that limestone. And that's just formed from, so basically shelled creatures dissolving. Their shells dissolve in the water, and then that's laid down as sedimentary rock. All right, and then so basically this is just talking about what I described, but calcium carbonate is what the shells are made out of, and that dissolves in the ocean, and that forms these layers underneath as it settles, and then basically over thousands and millions of years, we form limestone. Is the main source is calcium carbonate, and that would just be the shells from the organisms. That's where we get limestone, and that's it. Hope you enjoyed.